So from the examples that have been solved in the previous slides, we see that how can we obtain the confidence, how much we are confident that this stallion is clean, or didn't or doesn't carry the certain recessive allele. Now we do need to look for the number of mates, the opposite, assuming that we are having what we call the confidence for this certain animal. This question, if we want to go, if we are or want to, if we are want to have 94% confidence in test results using daughters, the same level possible using 10 known carriers. So in this case, we will use the second equation, given that we are aiming to have 94% confidence. So we will use this equation, n equal to the log of 1 minus the probability of the confidence of probability of the confidence over the probability of being B capital plus 3/4 of the probability of B capital B small plus half of the B capital B small. So by applying this equation, and we know that we are willing to have 94%. So applying, instead of a probability of dn here, we will add 0.94% to be log of 1 minus 0.94 over half plus 3/4 of times of half plus half of 0 multiplied by 0. So why do we add half here? 0.5. 1 over 2 for the B capital, probability of being B capital, or the probability of being B capital, B small. This is because we are using the daughters of the same possible stallion, and we know that if this stallion is carrier for this certain recessive allele, we know that the probability of obtaining this recessive or the genotype of the offspring will be 50% for to be B capital or heterozygous, and also the other 50% will be B capital. So because of that, we add half here, or 1 over 2, or the other to B capital, or 1 over 2 to the B capital B small multiplied by 3 over 4, but 0 to B small, because we don't know, we didn't use B small in this question. So the log of the result of the algorithm here will be 21 matings. So we need 21 sire-daughter matings to achieve the same level of confidence obtained from the 10 matings with known carriers. This is how can we deal with such problems. Also, one offspring. In the second case, the previous case was just only by using one offspring per mating. One offspring per mating and multiple groups here of mates. Previously, we are dealing just only one uniform mating type. Here we'll use multiple group of mates when there is more than one group of mates. For example, a group of known carriers, a group of daughters, and so on. We do need to use the following formula to calculate the level of confidence for the test. The probability, the confidence, probability of the confidence, probability here will be equal 1 minus this symbol, which is the product computation for each group, okay, multiplied by the product computation for the probability of being B capital plus 3/4 of the B capital B small, or half of the being probability of B small to the power of ni. Ni here is the counter referring to the different groups of mates. K here, K over the cross product. The product is the number of groups of mates that we are using, and so on. Example here, say we had 20 mares. Example, say we had 20 mares for the test, 5 of which are known carriers, and 15 of which are daughters of the stallion. So we have two different types of mates. One of them is known carrier, and the second are the daughter. We merge them together. We did this two types of mating, just only to know or to be sure that this stallion is clean. So we will apply this equation. The probability, the confidence, the probability here, the confidence is equal to 1 minus the product of the B capital, B capital, probability B capital, B capital, B capital, B small, and so on. So we'll apply it by using 1 minus here probability of being B capital for the first mate, 5 of which so the first product by using the 5 non-carriers, by applying this equation for this set of probabilities, since they are non-carriers, the probability of being B capital is 0, the probability of being B small is 0, but the probability of being A capital A small or heterozygous will be 1, so we'll multiply 3/4 of the by 1 in this case, and to the n here will be 5 because we use 5 animals, 5 non-carriers. Though this component will be multiplied by the second mate, which is the daughters, by the daughter of this stallion that are 15. By using the daughters, we do need to understand that is the probability of being B capital will be half. The probability of being B capital B small will be half, 50%, 50%, and the probability of being B small will be 0, and in here will be 15. So by applying this equation, it will yield around 97%. 97%. Again, I will explain it again. By applying this equation, we do need to add 1 minus the cross product of the first mate with the second mate, the second mating with the second with the first mating with the second mating. The first mating is 5 of which are non-carriers. Since they are non-carriers, as we see here, the probability of being B capital is 0, the probability of being B small is 0, but the probability of being B capital because B capital B small, they are heterozygous, so all of them will be heterozygous, so we'll add 1. In the second mating, they are non-carriers. They are daughters of the stallion. Since they are daughters, if the stallion is carrier, half of them will be B capital, and the second half will be small p small. So 50% will be added to the probability of being B capital, plus the 0.5 multiplied by 3/4 of the being heterozygous, leave B capital B small and 0 for B small, and we apply 15. The n will be 15 in the daughters and 5 for the non-carriers, and this will yield 97% at all. And thank you.